So this was the part that we're doing in functions, how a graph of a function looks like. Okay, and we saw the property that a vertical line should not intersect the graph in more than one point. Vertical line intersects in 2 points means that particular x has two images, which does not makes it a graphs of some basic functions. Okay, so first we will see the algebraic functions, or for that matter let's consider first the constant function. Okay, so for example, constant function means what? Let's say f from set A to set B is called a constant function, where f of x, let's say some particular y naught for all. I hope you know the meaning of these symbols. There exists, for all, belongs, etc. In set theory we have studied all these symbols. For all x belonging to R. For that matter, let me just write it here. For all x belonging to the domain set A. That is, each and every element of the domain set, they have the same image. Okay. So on the arrow diagram, it will look something like this. There may be some extra points in the codomain. We need not worry about the extra points. It may have a pre-image, they will not have pre-image, but all the points in the first set, they have the same image. Exactly the same image. So constant function, if I give you an example, let's say how the graph on the real valued constant function. Real valued constant function means a function defined from the set of real numbers to the set of real numbers. So real valued constant function, consider f of x is equal to 2. That's it. So how the graph will look like? The graph of this real valued constant function looks like, so the x-axis is the domain axis, the y-axis is the image axis. Now for x is equals to 0, my image is 2. For x equal to 1, my image is 2. For x equal to 2, my image is 2. For x equal to 3, my image is 2. X equal to -1, the image is 2. X equal to -2, the image is 2. So whatever x you take, each and every time the image is 2, 2, 2, 2, 2, 2, 2, 2. So my graph will be a horizontal line passing through the point y is equals to 2. Passing through the point 0, 2, or let's say the equation of the graph will be y equal to 2. This will be the graph of the constant function, a horizontal straight line. Okay. Next basic function is, let's say, the identity function.
Sir, one scroll down, sir.
Okay, just 1 second. So now identity function is what? A function defined from set A to the set A itself. And what is the definition of this function? The definition of this function is this x should be, what should be the image of x? Means f of x for all x belonging to A. Means x is an element in the domain set. So what should be the image of that element? The image should be x itself. It means each element will be related to itself. Each element will, the image of that element will be itself only. So let's say something, the identity function arrow diagram will look something like this. This is my set A, this is my set A. Let's say this is PQRS, PQRS. Here also PQRS, 4 points. And the identity function P will be related. The image of P will be P. The image of Q will be Q. The image of R will be R. And the image of S will be S. So the identity function in a real value, the real valued identity function, the real valued identity function, if I give you F defined on the set of real numbers to the set of real numbers, where F of X is equals to X. Can you see the real valued function will be something like this. This is actually the equation of the line y is equals to x. Sir, f of x, where do we plot that f of x? We know that we plot f of x on the y-axis. So what actually I'm telling you to plot? I'm telling you to plot f of x, you're plotting on the y-axis. So y is equal to x. This is what I'm telling you to plot. You take x equal to 0, the corresponding image for x equal to 0 is 0. You take x equal to 1, the corresponding image for x equal to 1 is f of x, f of 1 is 1, f of 2 is 2, f of 3 is 3, f of 4 is 4, f of minus 1 is minus 1, f of minus 2 is minus 2, and so on. This graph we have plotted in school. Also plot the graph of the line y equal to x, y equal to 2x, y equal to 3x, and so on. Okay. So this is the graph of an identity function f of x equal to x, y is equals to x. Either you can call it y is equals to x, or you call it f of x is equals to x. Okay.
Sir,
Yes, tell me.
sir, this both functions once again will you explain?
Sorry, what?
This both functions once again will you explain, sir?
The second function?
Both constant and identity.
Both.
Yes, sir.
Constant function is what? Constant meaning what? Value does not change. So f from set A to set B. So whatever is the value in set A, whatever value you take in set A, whether it is for P, Q, R, or S, you can vary set A, but their image will not vary. For if you take x equal to P, the image will be this particular point. Even if you vary the x, that is, if you take the image or original element Q, the image will be same this particular point. Call this particular point as, let's say, 5. For R also the image is 5. For S also the image is 5. If there is some other point T, for that also the image is 5. How do you write it in the letter notation format? For all x belonging to A, whatever is the x belonging to A is my domain set. Whatever x is my domain set, the image f of x equal to y naught, this y naught is fixed. Whether I'm changing it according to x, no, I'm not changing it according to x. So this example I gave you, from the set of real numbers to real numbers, consider f of x equal to 2. So for x equal to 0, how do you plot the graph? Plotting of the graph we have done in the last class. I hope you remember that. So for plotting of the graph, how do you do? So we take x equal to 0. What will be the image of x equal to 0? So image of x equal to 0, we plot it on the y-axis. And the y-axis, the y coordinate for x equal to 0 will be what, sir? F of 0 is 2 only. So for x equal to 1, what will be the corresponding y coordinate? So for x equal to 1, the corresponding y coordinate is again f of 1. F of 1 is 2 only. For x equal to 1, I plotted the corresponding y coordinate over here. For x equal to 2, I plotted the corresponding y coordinate over here. For x equal to 0, I plotted the corresponding y coordinate. For x equal to minus 1, I plotted the corresponding y coordinate. So for all the x's, I plotted the corresponding y's. Y's means the corresponding images, and I joined those images. So when I joined those images, it will be a horizontal line. Yes or no? I think
Yes, sir. Yes, sir. Yes, sir.
Then for identity function also, identity function is what? Sir, f of x, which p will be related to p, q will be related to q, r will be related to r, s will map to s. So for example I gave you from r to r, f of x equal to x. So 1 will be related to what? So what will be the image of 1? So the image of 1 will be mapped to 1 itself. So what will be the image of 2? 2 will be mapped to 2 itself. What will be the image of 3? 3 will be mapped to 3 itself. So I took x equal to 1. So x equal to 1, what was the corresponding image? The corresponding y is 1. For x equal to 2, I take the corresponding image. But where do I plot the image? On the y-axis. So my corresponding image is 2. For x equal to 3, what will be my corresponding image? My corresponding y will be 3. I joined all those points. Y equal to x is a straight line. Got it?
Yes, sir.
Now, this was identity function. Now we will see some basic polynomial functions. Okay. Polynomial functions is what? All the kinds of polynomial equation, you know. A polynomial expression is given. Now how to find the polynomial expression? So in the, let's say, 3.a. 3.a is what? A polynomial of degree 1. Polynomial of degree 1 means, let's say, f from r to r. Okay. So polynomial, let's say, consider f of x is equal to 2x plus 5 below. Yeah, take it 2x plus 5. Second, f of x is equals to quadratic. This was a linear degree 1. Degree 0 I have already given you. Degree is equals to 0. That is a constant polynomial. Okay. Degree equal to 1. Graph I will tell you. Degree is equals to 2. Let's say 3x square plus 4x minus 1. Degree is equals to 3. Let's say, it's the cursor. F of x is equals to, let's say, 5x cube minus 2x square x minus 1. Now 2x plus 5, you can see for yourself, the graph will be something like this. I'm not explaining the basics of this now. 2x plus 5 graphs you have drawn in school also. So the graph of 2x plus 5 will be like this. Positive slope, negative slope, that part we will see in coordinate geometry also. This year also we have 2x plus graph will be something like this. What I want to highlight here is how the graph polynomial expression depends on its leading coefficient. Leading coefficient, for linear it's a straight line. For quadratic we have already seen. Quadratic, the graph is, forget about the y-axis. The quadratic, it takes a single turn. Okay, it's a straight line here. Then for quadratic it takes a single turn. For cubic it will take two turns. For cubic it will take two turns. So you along plus infinity the graph is something like this. Then it goes something. Take two turns. 1, 2. Okay. So this is the graph of a cubic polynomial. What will be the graph for biquadratic? For biquadratic, the graph will be something like this. F of x is equal to, let's say, 10 times x raised to 4 plus, let's say, 6x cube minus 5x square minus 2. So the graph will be for one curve, second curve, and third curve. In all these graphs, I have made sure that all the graphs that I have drawn, I have made sure to make the leading coefficient. Leading coefficient is positive in each of the cases. Okay. During the explanation of quadratic, I have told you this point. What depends on the leading coefficient. For JEE purposes, we have another chapter, transformation of graphs, that we will see on the transformation of graphs. We will again revisit quadratic a little bit, and we will again see how to transform these graphs. Now the corresponding comparisons with negative coefficients. The corresponding comparisons with negative coefficients, let's say 3.8 from A to A only. F of x is equals to, let's say, minus 3x and plus 10, suppose. So minus 3x plus 10, the graph will be something like this. Okay. Then for f of x, second, f of x is equals to minus 3x square, and the remaining terms I'm taking on my own, plus 5x plus 1. Whether it will cut the x-axis or it won't cut the x-axis, right now I'm not checking those points. Okay, whether or not it will cut the x-axis or not, that depends whether or not the expression equal to 0 have real or imaginary roots. So we are not going as of now into those details. Right now I'm only telling you the shape of the equation. So if the graph does not have any real roots, it will lie completely above the x-axis. Okay, that part we have seen in the graph, in the expression of quadratics. Okay.
So once can you scroll down, sir?
Yes, 1 minute.
I mean up, sorry.
See, take here, then second, then 3. I will just draw all the graphs. Then I will zoom out and you can write. Okay. Just let me complete all the graphs first. F of x, cubic polynomial with a negative coefficient. Take any negative coefficient, let's say minus 5x cube, and the remaining as you like, plus 10x square minus 3x minus 1. So combined result. Now see, I have not checked these coefficients together in the combination whether or not they will give me 3 real roots or only 1 real root. But the graph will definitely be of this shape. This shape means what? This shape can occur in this way also. How? Means along positive infinity it will go. Means x tends to positive infinity. When x goes to positive infinity, graph will be downwards. So you take one turn and another turn. So this graph suggests that this equation has exactly 1 real root and 2 imaginary roots, or maybe the graph could have been this way: 2 real roots and your third. Okay, 3 real roots. Okay, then it will intersect completely the x-axis, or in 3 points. Or it may happen that the graph is something like this. 2 points above and 1 here. But the shape is similar. Observe the shape. Okay, I'm just telling you the shape, how the shape will be. Relative position with respect to x-axis, at how many points will it cut? We are not going in that details now. I'm just giving you the shape. Okay, and then 4 is equals to negative 10 x raised to 4 plus 6x minus 7 square minus 5, let's say. The graph will be downward direction w. Downward direction w, 1, 2, 3, 4. This is also w. Okay, not necessarily that all completely below the x-axis. Okay, it may intersect in 4 points also. Okay, take the screenshots or write whatever you want to write here. Shall I scroll down?
That's it.
Okay, and then this. Okay.
That's it.
Okay. Make sure, keep in mind the leading coefficient. It only depends on leading coefficient will determine whether the graph is upward or downward, and then all the coefficients combined will determine at how many points it will cut the x-axis. How many roots does it have? Okay. So to summarize, it's something like this. Linear. Now leading coefficient positive. Leading coefficient positive, that will keep it fixed. Leading coefficient positive. For linear it is this way. For quadratic it is u. For cubic 1, 2, 3. For biquadratic is 1, 2, 3, 4. For 5 degree, how it will be? For degree 5, 1 turn, second turn, third turn, fourth turn. Are you getting it? How to draw the graphs? For 6 also you can draw. And now for the negative leading coefficient negative, just keep it downwards. Okay. So I hope this will be clear. Now moving ahead, this was for the graphs of a polynomial equations. I am particularly interested in the graph of a quadratic equation. Okay, so quadratic in complex numbers chapter is left for us, right? Okay, but quadratic equations, that chapter is over. So quadratic equations, that quadratic expression, that graph we will analyze a bit. Okay, quadratic expression. So f of x is equals to ax square plus bx plus c. So in the last class, in the 10th standard, we have already seen that if a is positive, it's upward u, and if a is negative, it is downward u. U is parabola. That parabola we will see afterwards. Okay, so completing the square method we have seen in detail. Completing the square method as we have already seen in detail. So just to analyze the graph of the quadratic expression, I will need that completing square method. So right now we are not plotting the graph of the equation ax square plus bx plus c equal to 0. What are we plotting? We are plotting y is equals to ax square plus bx plus c. To find roots of the quadratic equation, I hope every one of you remembers the completing square method. Completing square method we have done when we were doing quadratic equations. this part, formula for roots of a quadratic equation. This part, do you remember? This rough we used to do how to find the number to be added to make it a perfect square. That part will be revisited now. So just pay attention. So I will just take a common. This is y is my f of x, the image of the point x. So to make it a perfect square, I will just take a as common. So if I take a common, actually I want to tell you that the graph is symmetrical, and what happens at this bottom point u, what happens at this bottom point u, and I want to convey you the message that this graph is actually symmetrical about this vertical line of the bottom point passing through the bottom point. So to convey that message, I'm doing all this such things. Ax square plus bx plus c, I will make it into a complicated expression. What that complicated expression is, so take a common. Okay, if I take a as common, the equation remaining is a as common, then x square addition b upon a times x addition c upon a. This much clear? If anyone has doubts in any step at that very point, unmute yourself and ask me. Okay. Now after this, since a is common, now inside the bracket x square addition b upon a times x, and this addition c upon a, this is as it is. Okay, now I only want to make sure to this to make it a perfect square something. So perfect square, how do? We add a suitable number so that the first three terms, the x square term, b upon x actually plays the term of means x square plus this plus the purple box. They three combinedly is the expansion of p plus q complete square, x plus something complete square. So in order to make that, I will have to add a suitable term, but I cannot add a term on my own. The maths, I cannot change the expression. So in order to not to disturb the expression, I will have to subtract that same term itself, so that the ultimate result is I'm actually adding 0, so that the expression is not disturbed. So now the rough work I will do, what expression should I add, what number should I add to make it a perfect square? X square addition b upon a times x plus some box. Okay, so it is something x plus another box x plus blue box complete square. So x, it's related to square. Now 2 into x into blue box. 2 into x into blue box is the middle term. Not the middle term. Twice AB term. P plus q complete square. P square twice PQ. Twice PQ is 2 into x into blue box. That is b upon ax. So the what will be the come into the blue box? Blue box value will be b upon 2a. So the purple box value will be b square upon 4a square. This part we have studied in quadratic equations chapter, so I'm not that's why it took very fast over here. So this number that we will add here is b square upon 4a square, and that same number we will subtract also, b square upon 4a square. So as soon as I add and subtract these terms, means actually I have not changed anything. So what result it's what that gives me is this three things combined, x square plus b upon ax plus b square upon 4a square. These three things combined gives me the result x addition b upon 2a complete square. X addition b upon 2a complete square. And then last simplification is, sir, a and 4a square, the LCM of the denominator is 4a square. So that it becomes 4ac minus b square. What is this expression? This expression is the complicated form of the simple expression ax square plus bx plus c. This simple expression I have converted into this complicated form, but that will be useful to us further. Why that will be useful, I'll just tell you. That will be useful only in the analysis of the graph. Don't memorize this expression. If you want to calculate the image of a point, calculate the image using the first expression only, not by this complicated expression. Till here, this process, this algebraic simplification that I did, or let's say algebraic complication that I did, any doubts? Okay. So now if this point is clear, now just I will give you a short glimpse of what is graph transformation. Since we are dealing with graphs of all the functions, I will also just give you a glimpse of graph transformations. So just rub this part. If I tell you, draw the graph of simple f of x, y is equals to x square. If I tell you to draw the graph, can you draw the graph y equal to x square? Yes, sir. It's very easy. The graph will be a U shape. X equal to 0, 0, x equal to 1, 1, x equal to 2, 4, x equal to minus 1 is also 1. The image of x equal to minus 1, the 1, x equal to minus 2 also the image is 4. So the graph is symmetrical about the y-axis. Everybody agree with me? No doubt here. Y equal to x square, very simple graph. If x equal to 1 has the image 1, x equal to minus 1 will also have image 1. X equal to 2 has the image 4, minus 2 also will have image 4. 3 has image 9, minus 3 also have image 9, and so on. Simple. X square you can draw. Yes or no? Now, if I tell you draw the graph of y is equals to x minus 1 complete square. Now what to do? If you think, sir, x minus 1 complete square is given, so I will go on expanding. I will expand x minus 1 whole square, that is x square minus 2x plus 1. So instead what I will suggest to you is, don't expand. Just let it be x minus 1 complete square. X is equals to 1. So what happens at x equal to 1? Sir, when x equal to 1, now this is some bracket square. Think of it, read it as bracket square. When x is equals to 1, the bracket is 0, so the corresponding image is 0. When x equal to 2, x equal to 2, the bracket is 1. X equal to 0, the bracket is minus 1. X equal to 0, the bracket is minus 1, so minus square is 1. X equal to 3, 3 means what? 3 minus 1, 2. 2 steps ahead of this, bracket is 2. Bracket is 2 means 4. X equal to minus 1. So minus 1 is minus 2. The graph is something like this. So what my claim is, sir, x square and x minus 1 complete square graph is exactly same. Exactly. Just the case that this graph is shifted 1 units to the right side. Means if you are dealing with centimeters, you just pick this u, you pick it up, sir, and you shift it to the right 1 centimeter. This bottom point 0, the bottom point which was at 0, that bottom point is now at 1, and the whole thing, the whole u, it maintains its shape and it is shifted to the right by 1 centimeter, 1 unit, whatever that unit is. If I give you x, y is equals to x minus 2 complete square, x minus 2 complete square will be what? So the graph of x minus 2 complete square will be, so take the original graph x square and shift it 2 units to the right. So x equal to 1, and here the graph will be there. So my drawing is not perfect. It will be a U shape. My drawing I have drawn in the form of a, don't bother about my drawing. It's a symmetrical about the point x equal to. It will be completely symmetrical about these points, about these lines, vertical line X equal to 1, X equal to
Sir?
minus 1. Yes, tell me.
Won't it be one above for the x minus 2 whole square?
Yes, this is the graph of x minus 2 whole square, the third graph that we have drawn.
No, sir. I'm saying like even if you substitute x is equals to 1,
Yes.
it'll become 1, right?
Yes, see, if x equal to 1,
Why?
for x equal to 2, the graph is, the image is 0. For x equal to 1, the corresponding bracket is minus 1. So minus 1 complete square. So y, the y is 1. For x equal to 0, this point is 4. This point is 0, comma 4. This point is here for x equal to 3, it will be 4. And here x equal to 4, it will be 4,
Okay.
comma 4.
Okay.
Can
Sir.
you see? Means
Yes.
it is something like this. This point 1 and point 3, they are brothers. Point 1 and point 3 are brothers. Point 0, x equal to 0 and x equal to 4, they are brothers. X equal to 3 units, 2 units to the right of 2, 2 units to the left of 2. 3 units to the right of 2, 3 units to the left of 2. Think of it this way.
Okay. Sir.
Okay. Makran, Nitin, Pujita, are you getting everyone? Pujita?
Yes, sir.
Yes, sir.
So these graphs in the shape also, they are exactly similar. Now, what happens if I just do one small alteration? Y is equals to x square plus 2. So x square plus 2, if I do, what will happen? This is my xy axis. So for x square plus 2, it will be so for x equal to 0, 0 square and addition 2. X equal to 1, 1 square I know, 1 square addition 2. 2 square I know, addition 2. So means what actually is adding? So see, the original graph that we have, the original graph above here, where my cursor is, the original graph shape we know. The original graph shape that we know, those y, in that original y, you have to add 2 at each and every point. Original y plus 2, original y plus 2, original y plus 2. So can you see that the new image, the new y, the new image will be this original 0 addition 2. So this 2, 0 will come over, shift by 2 units upward. For x equal to 1, the original y is over here. This will shift 2 units upwards. For x equal to 2, the original y is over here. This will shift 2 units upwards. For x equal to minus 1, the original y is over here. This will shift 2 units upwards. So can you see the new graph? The graph of x square plus 2 will be what? Sir, it will be exactly same as x square. Just difference, it will be shifted vertically upwards with 2 units, 2 centimeter you can say. This point is 0, 2. Okay. This point is 0, 2. This graph. And U shape, the U shape is exactly matching. Matching means the curvature and all those things, they are exactly matching. It's just shifted above 2 units. Similarly for x square, if x square plus 2 you can draw. Can you draw the graph of x square minus 2? X square minus 3 for that matter. Y is equals to x square minus 3. So this is my graph of this part. We will graph transformation, we will study in detail in the other special chapter, transformation of graphs. Right now I'm dealing with only for quadratic. So for x square minus 3, the graph will be something like this. The graph of x square exactly, and it will be shifted 3 centimeters downwards or 3 units downwards. 0, minus 3. The graph will be shifted 3 units downwards. Any doubts here? And now
No, sir.
the graph of y is equals to x minus 1 complete square plus 5. I hope everyone can draw. So the graph of x minus 1 complete square, how to draw it? First, we will draw the graph of x minus 1 square. Instead of x square, forget about x minus 1 complete square plus 5. Concentrate only on x minus 1 square. and prior to that concentrate only on x square. So we know the graph of x square. From here we jump to x minus 1 square, that is shift. We shift the graph right side 1 centimeter, and then we shift this graph. We shift this graph 5 centimeter upwards. Okay, this point, whatever it will be. This graph is shifted 5 centimeter upwards. Now, if I give you x minus 1 complete square negative 10, that will be the original graph will be shifted 10 centimeter. So now the only matter is what happens with this a. Okay, yeah, see one thing, x minus 2 you have drawn. So what will be the graph of sir x minus 2 you have already seen. Okay, what will be the graph of sir y is equals to x addition 3 whole square. X square you have seen, x minus 1 square you have seen, x minus 2 whole square you have seen. What will be the graph of x addition 3? Nothing major difference, exactly same, just the bottom of that hill. Don't read this x plus 3. Instead of reading x plus 3, read it as x minus of minus 3. So that bottom of the hill will be negative 3 and the same graph will be shifted leftwards 3 centimeters. This original graph of x square will be shifted leftwards 3 centimeters. Okay. And now if I tell you the graph of x plus 3 complete square plus 10, or let's say minus 10, then this U shape will be shifted upwards 10 or downwards. Now the only question remaining is, if x square I can draw, sir, x square I can draw y equal to x square. This is my graph of y is equals to x square. Can you tell me the graph of y is equals to x square with a negative sign, that is minus of x square. I'm not telling minus x whole square, minus of x square. So it should be easy to see that x equal to 0, 0. For x equal to 1, initially we were pointing x square, that is 1. So now what we are doing, the square, that is 1 with a negative sign. For x equal to minus 1 also minus 1. For x equal to 2, initially 4, now it is minus 4. For 3 it was 9, now it is minus 9, minus 16. So the same graph, but it is now inverted, exactly same shape. Take a water reflection. You have just taken a water reflection of that graph, or let's say a reflection about the x-axis. Is that clear?
Yes, sir.
You can do, I hope. I will just draw one graph. Y is equals to x minus 5 complete square. This is made negative of x minus 5 complete square, and let's say 10 is added to it. So see how I will draw. I will draw this graph in multiple steps. First, I will draw the graph of, this is my xy axis. Okay, this is my xy axis. So first I will concentrate only on this purple part, x minus 5 whole square, and that too with a negative sign. So this is my, let's say this is my 5. Okay, 1 2 3 4 5, 1 2 3 4 5. X minus 5 complete square. So x minus 5 square is something like this. I want to make that negative. So if I make that negative, it will be something like this. Correct? And now I want to add 10 to it, or let's say for the to avoid dirtiness in the diagram, I'm making it minus 10 to make the diagram little bit neat and clean. X negative of x minus 5 whole square I have drawn, and now subtraction 10. So this u will shift downward, so it will be symmetrical about this axis. Clear? Now the what does this A matters? This A should also matter something. A multiplied by whole such things. So for that thing, y is equals to x square. And y is equals to 2 times x square. Ten times x square. So see, 0 for x equal to 0, 0, x equal to 0, 0. The bottom point remains the same. For x equal to 1, see the initial point, 1 and minus 1, they are brothers. X equal to 1 and x equal to minus 1, they are brothers. Their images 1 and 1. In the second case, their images, now it is 2 and 2. In the third case, the image is 10 and 10. Now see, just concentrate on 2x square. If you think that see x equal to 1, x equal to minus 1, initially the image was 1, now the image is 2. So the graph shifted 1 centimeter upwards. No, the graph did not shift upwards. For x equal to 2, the image is 2 square 4, 4 2s are 8. You see now, depending whatever the x plus b upon 2a whole square is, depending on that value, the graph, the base of the bottom graph is the base of the hill. It is similar to x square only. The graph will either be this way or the graph, yeah, that graph will be that way only. Not x addition b upon 2a. So this bottom point is minus b upon 2a. Everybody realize this? Yes or no? Now also take in mind, minus b upon 2, it's not necessarily negative. Minus b by 2a can be positive also, right? So y-axis can be, y-axis may be over here, according to that, by which minus b by 2a is positive, or maybe that the y-axis is over here, which will take minus b upon 2a as negative. So I'm not worried about the y-axis, where the location of the y-axis is. So what I want to tell you is y-axis can be anywhere. You can shift this graph horizontally as much as you want, to the right as much as you want, to the left as much as you want. So I will just draw the graph without the y-axis. Without the y-axis, the graph will be something like this. X addition, the simple graph related to minus b upon 2a whole square. And now the bottom point of the hill is minus b by 2a. Now once you get this bottom point, now x, this blue bracket whole square graph we have drawn, blue bracket addition something. So blue bracket addition something. Now depending what that 4ac minus b square upon 4a square, whether that is positive or negative, this graph, it may either be shifted upwards by how much magnitude? The magnitude will be 4ac minus b square upon 4a square. It may either be shifted upwards or it may be shifted downwards. Correct? But whatever the case, it is either shifted upwards or it is shifted downwards. If this 4ac minus b square upon 4a square, if it is negative, so we are adding a negative number, so means actually it is getting shifted downwards. So whatever it, whether even if it is shifted upwards or even if it is shifted downwards, the bottommost point of the hill, it is remaining the same only, minus b by 2a. And also another result that we have is about this line. Which line? About this red line, the vertical line passing through x equal to minus b by 2a. The vertical line passing through x equal to minus b by 2a. The graph is symmetrical. whether you take y equal to x square or x minus 1 whole square or x minus 2 whole square, graph is symmetrical about that point. So it is x addition b by 2a whole square, graph is symmetrical about that point. And this whole purple means addition, this whole purple that you have drawn, when you multiply it by a, you are only actually changing the curvature of that u. If a is positive number, so yes, you have changed the curvature. Means see, now this was our initial curvature of x square, or let's say this bigger bracket, the blue bracket square addition, this whole thing. This was our original graph, and when you multiply it by, let's say, positive a, so positive a, so you have just changed something like this, and the graph will be positive only. And if you multiply it by negative a, so negative a, the graph will be same, just in the terms of negative, so the graph will be same. Only the curvature will get changed and nothing else. So final graph with all the final so the final graph, I will just draw the result. Only two cases. Either this or this. Whether or not it will intersect the x-axis at 2 points, that depends. But this topmost point of the hill or the bottommost point of the hill is minus b upon 2a minus b upon 2a. So for a quadratic expression, this was whole thing. This was a complicated form of the simple expression ax square plus bx plus c. So now the remarks that I want you to write is, write these remarks. First, f of x is equals to ax square plus bx plus c. F of x equal to ax square plus bx plus c is symmetrical. Vertical line. What is the equation of the vertical line? It's x equal to constant. That is x equal to minus b upon 2a. Okay. Symmetrical about the vertical line, x equal to minus b upon 2a. Second remark that is there, if f of a if a is greater than 0, for a is greater than 0, what do we have? We have the graph as upward facing u, upward facing parabola. The symmetric condition will always be there. The graph, the expression f of x, that is the expression is f of x. Okay, f of x has minimum value, minus b by 2a. Keep in mind that minus b by 2a is not the minimum value of the expression. It is the value at which the expression has minimum value. Minimum value of the expression will be something different. Okay, minimum value at x equal to minus b by 2a, and maximum value and maximum value is infinity. And second point, in the second remark only, the another point is there, if a is less than 0, then f of x has maximum value at x equal to minus b upon 2a and minimum value is negative infinity. This graph. I hope it is clear till this point.
Yes, sir.
So can you scroll up? And also, sir, can you zoom out all the graphs which you did there?
This part will be again. This part will again be dealt in transformation of graphs chapter. It is not for the boards. Transformation
Okay,
of graph
sir.
is not for the boards. It is only for J. Okay.
Okay, sir.
So now I hope in while dealing with quadratic equations, I have told you the different cases of the graphs, I suppose. Check. Did we see the different cases of the graphs? A greater than 0, D greater than 0? No, I don't think we saw that. Yes, these cases we have already seen during quadratic. These cases, okay? If A is greater than 0, the three possibilities: discriminant greater than 0, discriminant equal to 0, and discriminant less than 0. Okay. So should I skip these six graphs now here?
Yes, sir.
Okay, this if A is less two real roots, it cuts x-axis at 2 points, single point at no point. This part we have already seen. Okay. Now, so this minimum value of the f of x and maximum value of f of x that we have seen. So this second remarks gives you the range of ax square plus bx plus c. This question is useful to find the range of a quadratic expression. For example, if I tell you, let's say, okay, and value at f of this point, the graph, the particular discriminant, this is minus of d. Can you see this? B square minus 4ac, we call b square minus 4ac as our d, not discriminant. Under root discriminant जो लेते थे अपन, that we take as under root d, that is b square minus 4ac only. So at x equal to minus b by 2a, at x equal to minus b by 2a, is my y becomes, so this blue bracket becomes 0, and this thing expression becomes minus of d upon 4a square multiplied by a. So can I say that the y is minus d upon 4a? Y is minus d upon 4a. Yes or no, everyone?
Yes, sir.
So no need to memorize this. You can just you can minus b by 2, you can that value substitute over here. So let's say consider this example now. Examples for the domain and range of quadratic expressions we will do. Find the range of f of x is equals to x square minus 6x plus 9. Anybody? Come on, it's not that easy. Find the range. Range, it's the maximum, minimum, everything. It's not that difficult. See, here, this question I have straightforward given you f of x as a perfect square. You can see that f of x is nothing but x minus 3 complete square. So here you can see that from the graph also, if you just imagine the graph. Now actually for this, since you have seen the graphs of the quadratic expressions, you have seen the transformations also for quadratic. So you should be able to see that the graph is something like this. Graph of x square is a u. So x minus 3 whole square graph will be this shape u. Yes or no? This point is what? So this point is 3, x equal to 3. So what is the range of f of x? So minimum point, minimum value of f of x is this only, that is f of x equal to 0. That's the bottommost point, and the topmost point of the graph, the topmost point of the graph is infinity. It has no topmost point. So each and every value above 0, including 0, so 0 to infinity. Done. But here we were lucky. That so this x square minus 6x plus 9, you gave it to be a perfect square. If it is not a perfect square, then what, sir? You should, the universal method is you should always convert it into this form. Simple expression, you convert it into a into this perfect square plus something this, and then you can analyze. But that transformation, we have already converted that transformation, and then we have memorized some basic results, that the centermost point is minus b by 2, bottom of hill or top of hill, and that we have already analyzed those things. So we will make use of that result. So that result, how to make use of that over here? So method 2, the standard means the shortcut method. Since we have already analyzed the results for quadratic and kept it ready. Sir, my a is equals to 1, b is equals to minus 6, and c is equals to plus 9. I have observed that, sir, here a is greater than 0. Since my a is greater than 0, I am very much sure that my graph is an upward facing u. So since it is upward facing u, and I have already analyzed the graph of quadratic equations in general, so I know that this graph is symmetrical about the bottommost point, and this bottommost point coordinate is x coordinate is minus b by 2a. So can I find the bottommost point? Yes, sir, I can find minus b upon 2a. So what is my b? Minus 6 upon 2a. 2a is 2 into 1. So can I say that my bottommost point is 6 upon 2, that is 3? So yes. F of x has minimum value at x equal to 3. F of x has minimum value at x equal to 3. So what that minimum value will be? Sir, what is f of 3? Just simply substitute 3 square minus 6 into 3 plus 9. You can see that 3 square is 9, 6 3s are 18 plus 9. So that turns out to be 0. Yes, sir, this is my bottommost point. The image, the corresponding y is 0, and topmost point will be infinity. So 0 into infinity, that we get. F minimum is 0, F maximum will be infinity. Done?
Yes, sir.
Okay. Find range of 1 minute. Okay. X square x square plus 9x plus 18. Sorry, equal to 0. I cannot write equal to 0. That will be a mistake. X square plus 9x plus 18. That's it. Write your answers in the chat box. For infinity, you can use a symbol F. F for infinity. No need to type the complete thing. Tell me the interval. And if you're not getting right, EXP. Okay, Makran, if your answer is 0 to minus f, then you should write minus f first and then 0. That is minus infinity to 0. Okay, but actually that answer is wrong. Okay. 0 to minus infinity, that interval does not exist. Correct interval is minus infinity to 0. And even then that answer is wrong. Minus infinity to 0 is not the answer for this question.
Say 0 to infinity.
Okay, positive infinity. Then also the answer is wrong. Okay. Pujita Dhananjay. See, range of x square plus 9x plus 18. Can you see that, sir? My a is equals to 1, b is equals to 9, c is equals to 18, and my a is greater than 0. Since my a is greater than 0, the graph of this quadratic expression is an upward facing parabola, symmetric about the bottommost point. And what this bottommost point is, so my bottommost point is minus b upon 2a. Can you calculate this minus b upon 2a? Yes, sir, I can calculate. This is the x coordinate. Okay. X minus b upon 2a. So that actually minus b upon 2 is minus of 9 upon 2.
It's 9/2. Yes.
So the minimum value of the expression occurs at minus 9/2. F of x is minimum at x equal to minus 9 upon 2. So you just have to find the image of minus 9/2. So f minimum is actually f of minus 9/2. Correct? So just substitute minus 9/2 in those in that expression. So x square, that is minus 9 upon 2 complete square addition 9 into minus 9/2 plus 18. Do the necessary calculations, and I think so the answer will come out to be minus 9 upon 4. I think this should be the answer if my calculations are not wrong. Okay. So the range of f of x range is equals to the minimum value is minus 9/4, attains this value, so equal to, greater than or equal to minus 9/4 up to infinity. There is no maximum value. Clear?
Sir, I did this calculation mistake. Sir.
Calculation mistakes you did. Okay. Done. Next question of this sort. This much should be clear that this function, it will have no minimum value. It will attain everything up to negative infinity. It will just have some upper limit, downward facing u. No. Pooja, your answer is 17 to infinite. How can it have possible answer? Means a maximum range to be, means the upper limit to be infinity. The graph is a downward facing u, no? Pujita. If it's a downward facing u, it won't go up to plus infinity.
Infinity, 70.
Dhananjay and Makaran, shall I explain? I think Pujita, you wanted to write minus infinity to 17, not infinity to 17. Minus infinity to 17, but I don't think that will also be correct. The answer will be fraction. So let's see. Okay, a is equals to -2, b is equals to 5, c is equals to minus
Sir?
1. Yes, tell me.
Is it minus infinity to 29 by -4?
Let's check. Okay, so a is equals to -2, which is less than 0. Okay, a is less than 0, so my graph will be downward facing parabola, and this the topmost point x coordinate is minus b upon 2a, and minus b upon 2a is actually 5 by 4, correct? Minus b upon 2a will be
Yes, sir.
5 upon 4. So f maximum is equals to f of 5 upon 4, correct? So
Yes.
f of 5 upon 4 will be -2 5 by 4 whole square addition 5 into 5 by 4 minus 1. So this turns out to be equal to 25 upon 16, and 16 is negative. This 2 I just reduced it. Here this is 25 by 4 and minus 1. So this turns out to be 50 minus 25, 25 by 8, and then minus 1. So this turns out to be 25 by 17 upon 8 it will be.
Sorry, sir, I forgot to take down denominator, sir.
Okay. So the range
Minus infinity, 17 by 8.
minus infinity to up to 17 upon 8, and 17 upon 8 will be included. Okay. Since this graph is -17, it is from negative infinity and it is going up to a positive value. You can see that it has two roots.
Yes, sir. So
Check b square minus 4ac also. B square minus 4ac is greater than 0. Two real roots.
Yes, sir. So one more sum, sir.
One more sum.
Yes, sir.
Okay. F of x equals to x minus 1 whole square plus 2 times x minus 3 whole square. Range is equals to question mark. If you are unable to solve, means don't know how to start, tell me in the chat box. I will give you a hint. No, Pujita, wrong. See, x minus 1 whole square, I will just tell you how to start. You just have to convert it into single quadratic. If you just convert it into a single quadratic, just expand it, it will be x square minus 2x addition 1, and this is 2 times x square minus 6x plus 9. So this is x square minus 2x plus 1 plus this is 2x square minus 12x plus 18. So my f of x is actually what? My f of x is 3x square minus 14x plus 90. So this sum is now same as the previous sums. Range of a quadratic, range of a quadratic, range of a quadratic. Now this can be solved. A, B, C, A is greater than 0, so it's an upward facing U minus B upon 2A, minus B upon 2A. That turns out to be equals to 7 upon 3. X equal to 7 upon 3. So the range is f of 7 by 3. F of 7 upon 3 will be the minimum value, correct? F of 7 by 3 will be the minimum value and the maximum value will be infinity. So just do the calculation. F of 7 upon 3. If my calculations are not wrong, f of 7 upon 3 turns out to be equal to 8 upon 3. And this infinity is as it is. This is the answer as per my calculations. Make sure you get the same answer. Pujita, is the 7 upon 3 correct, Pujita? X equal to 7 upon 3. At that point, the fraction of the quadratic expression will have minimum value. Whether this is correct, Pujita? Tell me, answer me this question.
Sir, correct only, sir.
Correct, na?
Yes, sir. Yes, sir.
So just substitute here 3 into 7 by 3 whole square minus 14 into 7 by 3 addition 19.
Yes.
Just substitute here and then check.
Yes.
Which is coming up in 8.